You are currently the only person in this conference. You are
Okay, so let us start. Do you have any questions from the previous class? Any questions? Okay, so in that case, we'll be solving problems on projectiles. Right, so you can note down one problem. A projectile aimed at a mark, a projectile aimed at a mark which is in a horizontal plane through the point of projection. So through the point of projection. Falls a meters, falls a meters short of it. When the elevation is alpha. And goes b meters too far, b meters too far when the elevation is beta. So that if the velocity of projection be the same in all cases, the proper elevation is half sine inverse a sine 2 beta plus b sine 2 alpha divided by a plus b. Can you try to solve this? So the way he has given is a projectile aimed at a mark which is in a horizontal plane through the point of projection, falls a meters short if the elevation is alpha and falls b meters away if the elevation is beta. So that means, so this is x-axis and this is y-axis and this is actually projected from here with certain velocity. Now actually there are two different cases actually he mentioned. So he tried aiming at this particular point, and then actually initially when the angle of elevation is this one, this is alpha, then actually it is falling a short of a meters. When the angle of elevation is beta, that is, this is the angle of elevation, then it goes away or far away from the point of projection to a distance of beta b. So that means actually he wanted to target this location, but actually in the first case when the angle of elevation is alpha, this is falling short by a. When he aimed at actually again with an angle of beta, then actually it is going too far for a distance of b from the place actually where he is targeting. Now actually what he asked was what should be the proper elevation, so that so this is proper elevation. I call this angle as theta. So theta is the proper elevation angle. Then actually you have to find out the angle theta in terms of AB and alpha beta. Got it? So can you try to solve this? Anybody got it? Okay. So let me solve this. See this, actually he is targeting this location, let us say P. Then this is A and this is B, let us say. So the angle of elevation initially it was at alpha, where actually it is falling short by a distance of A. Now actually the range of the projectile is given by R is equal to U square sine 2 alpha by G. So this is the range of the projectile in case of alpha is the projected angle. Similarly, the range of the projectile in case 2, that is R beta is equal to U square sine 2 beta by G. Let us say the proper angle is theta, and with which If the angle is theta, then the range should be u square sine 2 theta by g. So these are the three different ranges actually with three different projected angles. Now here actually in the first case, so A is equal to OP minus OA is equal to A. And OP is the first, so this range, which is the appropriate range, A is equal to u square sine 2 theta by G minus OA is this angle. So this one, u square sine 2 alpha by G. So if I take u square by G out from this relation, so we got sine 2 theta minus sine 2 alpha. So this value is equal to A. So you can note down this, then actually we'll erase and then continue this. Then okay. So A value we have got, it is coming out to be u square by G times sine 2 theta minus sine 2 alpha. Similarly, B value we can get it from OB minus OP. So OB is u square sine 2 beta by G minus OP is u square by G times of sine 2 theta. So if you take the ratio of A by B, then this is going to be sine 2 theta minus sine 2 alpha by sine 2 beta minus sine 2 theta. So if you take the cross multiplication, A sine 2 beta minus A sine 2 theta equal to B sine 2 theta minus B sine 2 alpha, or A sine beta plus B sine 2 alpha, A sine 2 beta plus B sine 2 alpha equal to A plus B times of sine 2 theta, or sine 2 theta equal to A sine 2 beta plus B sine 2 alpha by A plus B. So from this actually we can get the relation theta equal to half sine inverse of this entire value, that is A sine 2 beta plus B sine 2 alpha by A plus B. Got it? So this is how actually you can find out the relation between the appropriate angle versus the given angles in two cases. Note down one more. I hope it is noted. A shot fired at an elevation alpha is observed to strike the foot of a tower. Is observed to strike the foot of the tower. Foot of the tower, which rises above a horizontal plane. Above a horizontal plane through the point of projection. Through the point of projection. If theta be the angle subtended by the tower, if theta be the angle subtended by the tower at this point, so that the elevation required to make the shot strike the top of the tower. To make the shot strike the top of the tower. Is half theta plus sin inverse of sin theta plus sin 2 alpha cos theta. So can you try to solve this? So what is happening in this problem is a shot fired at an elevation of alpha, which is observed to strike the foot of the tower, which rises above a horizontal plane through the point of projection. That means, suppose this is the horizontal plane and this is the point of projection, and let us say this is y-axis, then this is the point of projection. There is a tower at this location. Now actually he wanted to, so he threw the projectile like this, and then actually it is touching the foot of the other tower, and then this tower is at an elevation of theta. So this angle is theta, and initial projected angle is alpha. So this angle is alpha. Now actually this information was given. He wanted to aim at the top of the tower. Now what should be the angle of projection? So this is how actually you wanted to strike it. Then actually what should be the angle of elevation like this? So this beta he asked us to find out. Got it? So this angle, this is theta, and the initial projected angle is alpha when it strikes the foot of the tower, and he wanted to aim the top of the tower. Then actually what should be the projected angle? In terms of theta and alpha, we should be expressing the value of beta. So this is beta. Can you try to solve this? I'll give you 5 minutes time. Anybody got it? Anyone got it? Okay, great. So let me solve it. So here, let us say this length, which is the distance of the from the projection to the foot of the tower, let us say this is r. Then actually this range from the initial projected angle of alpha, you can find out this is u square sine 2 alpha by g. So this is the range of the projectile. In case if it is projected with an angle of alpha, then actually it is hitting the foot of the tower. Now actually for the above path, this is projected at an angle of beta, then we have the projectile equation y is equal to x tan arc beta minus gx square by 2u square cos square beta. So this is the projectile relation. Now in this projectile relation, this y is nothing but the height of this particular projectile. So this is the height of the tower, and this height of the tower in terms of r we can express as r tan theta, because at theta also he has given. So r tan theta is the height, and x is this distance which is equal to r. So y equal to r tan theta and x is equal to r. Now if you replace in the projectile equation, so r tan theta equal to r tan beta minus gr square divided by 2u square cos square beta. And then actually we have got the relation of r. So this r value you can cancel once, and this tan theta equal to tan beta minus g into g by 2u square cos square beta, and then this r value we can replace as u square sin 2 alpha by g. So this g will cancel and u square cancels, and then we left with the simple relation tan theta equal to tan beta minus sin 2 alpha by 2 cos square beta. So this is a simple relation what we have got. Now here tan theta you can express as sin theta by cos theta is equal to sin beta by cos beta equal minus sin 2 alpha by 2 cos square beta. Now if you want to take the LCM, then actually you multiply with 2 cos beta here. So I have multiplied 2 cos beta on top and bottom. Then actually, so this is going to be sin theta by sin cos theta is equal to 2 sin beta cos beta is sin 2 beta divided by minus sin 2 alpha whole divided by 2 cos square beta. Now if you take this side to the other one, so 2 cos square beta into sin theta, 2 cos square beta, or else you note down this, I am going to erase it and simplify it. Then, so if you further simplify this relation, sin theta into 2 cos square beta equal to sin 2 beta cos theta minus sin 2 alpha cos theta. And this you can simplify as sin theta 1 plus cos 2 beta sin 2 beta cos theta minus sin 2 alpha cos theta. So this is sin theta plus sin theta cos beta cos 2 beta equal to sin 2 beta cos theta minus sin 2 alpha cos theta. So if you take this to the other side, then sin theta plus sin 2 alpha cos theta equal to sin 2 beta cos theta minus sin theta cos 2 beta. So if you notice, this is sin A minus B format. So sin 2 beta minus theta, and this side sin theta plus sin 2 alpha cos theta. So from this relation, 2 beta equal to theta plus sin inverse of sin theta plus sin 2 alpha cos theta. So this 2 you can bring it here, this is going to be half of it. Got it? So this is how you can solve the problems based on these projectiles. Note down one last problem. If alpha comma beta are two possible directions, if alpha comma beta are two possible directions, to hit a given point A comma B, to hit a given point A comma B, then show that tan alpha plus beta equal minus A by B. Then show that tan alpha plus beta equal to minus A by B. So can you try to solve this? Here actually, if alpha beta are two possible directions, that means if I wanted to project this, so I wanted to target a point here. Now actually this can be targeted like this, or this can be targeted like this, right? So both are possible. Now here actually this point, if I wanted to target it, in one case actually I have projected with an angle of alpha, and in another case I have projected with an angle of beta. Now actually if the coordinates of this point is A comma B, then we have to prove that tan alpha plus beta should be equal to minus of A by B. So this is what he asked us. Can you try to solve this? Anybody got the answer? Anybody got it? Okay, so let me solve it. See this. So for any projectile motion, right? So the equation is going to be given as y is equal to x tan theta minus gx square divided by 2 cos square alpha. 2 u square cos square alpha. So in this case, it is theta. Now actually, in general, for any projectile motion, so x tan theta minus gx square by 2 u square secant square theta. 1 by cos square theta is secant square theta. The same thing you can even write as x tan theta minus gx square by 2 u square into 1 plus tan square theta. Right? So here y is equal to x tan theta minus gx square by 2 u square minus gx square by 2 u square tan square theta. If you bring this to the other side, then gx square by 2 u square tan square theta minus x tan theta equal to plus gx square by 2 u square plus y equal to 0. Now in this relation, so this is actually any general projectile equation which is represented in a different format than this. The same thing is actually simplified to this format. Only thing we changed is that cos square theta actually we have made in terms of tan square theta now. That is the only difference. But here if you carefully notice, this is a quadratic equation in terms of tan theta. So tan theta is a quadratic equation. Hence, there are two possible angles for this particular tan theta. That means tan theta can have two different angles of alpha and beta. So where this equation is getting satisfied as long as this point actually passes through this particular equation. That means, so if I replace x with a and y with b, then actually this equation is going to be ga square by 2u square tan square theta minus a tan theta plus g a square by 2u square plus b equal to 0. Now this is a quadratic equation. Now tan theta can have two different solutions. Maybe theta equal to alpha and theta equal to beta. So these are the two possible solutions for alpha and for theta, so that this quadratic equation is getting satisfied. Now in such cases, right, so because alpha and beta are having the same solution, that is this a comma b is actually the point of passing through the both of the projectiles, then actually this quadratic equation sum of the roots will be tan alpha plus tan beta, and similarly the product of the roots is tan alpha into tan beta. So that is the sum of the roots and the product of the roots of this quadratic equation. We can find it out from here. Now there actually we can calculate the value of tan alpha plus beta, which is equal to tan alpha plus tan beta divided by 1 minus tan alpha tan beta, where tan alpha and tan beta value you can find out, which is the product of the roots for the quadratic equation, and sum of the roots is nothing but tan alpha plus tan beta, which is the numerator. So we can calculate those values and substitute here, so that you can find out the tan alpha plus beta value, which will be simplified to the form of minus a by b. First you note down this, we will do that. Got it? Okay. So from this relation, tan alpha plus tan beta, which is the sum of the roots, which is given as minus b by a, that is minus of minus is plus divided by ga square by 2u square. So this a will cancel and 2u square by ga. So this is the sum of the roots. And the product of the roots are tan alpha tan beta is equal to c by a. So ga square by 2u square plus b divided by 2u square by ga square. Now this is going to be, if you take this to the inside, this is exactly inverse of this. So this is 2bu square by ga square. This is the product of the roots. Now tan alpha plus beta equal to tan alpha plus tan beta by 1 minus tan alpha tan beta equal to, so sum of the roots are 2u square by ga divided by 1 plus 2bu square by ga square. So if you take the LCM of it, then actually this is 2u square by ga square divided by ga square plus 2bu square. This ga and this ga will cancel out. 2u square by ga square plus 2bu square. I think so. I have ignored this 1 minus this value here. So this 1 will cancel out, and then actually 2u square by ga divided by minus 2bu square by ga square. So this ga square and this ga will cancel out, and u square will cancel out, and then so minus a by b is left out. Yeah, that's all. Got it? Yeah. So this is how actually you can solve. So only thing, if you notice, right, so we didn't learn anything new. Whatever the analysis we have done yesterday, that analysis actually is manipulated here and there for the problem statements. That's all. So knowledge is only that one. Rest of the thing is your analysis, nothing more than that. Got it? Okay, so this is about the projectiles. In the next class, actually, I am going to start with the circular motion. So if you have any questions on projectiles, you can ask me now. Any questions on projectiles? Okay. So with this, actually, I would like to stop the class for today. In the next class, I am going to start with circle. Yeah. So that's all. Thank you.